Again, welcome to Principles of Epidemiology, Measure of Disease. This is our lecture number 2, part 2. So our main objective is to define and calculate prevalence, also define and calculate cumulative incidence and incidence rate. Also, we are going to explain and calculate person years of observation, and also explain the relationship between prevalence and incidence rate. So here we start with the three types of measures, which are prevalence, cumulative incidence, and incidence rate. So again, these are three types of measures for diseases. So all measures share three characteristics. Always we are going to have the number of cases as the numerator and the size of population as the denominator. This will give us a fraction, which is the prevalence. Then also the measure of time. With the measure of time, that's where we get incidence and incidence rate. Prevalence is proportion or percentage of the population that have the case. So it's the number of cases divided by the size of population. But when we are looking for the incidence will be the number of new cases divided by the population that have risk. Maybe because of their behavior, they are very risk to the problem. So an example would be if we have a community with HIV infection for the past 50 years is around 200, which means the total HIV cases is 200. The population size is 1,000. The prevalence will be 200 divided by 1,000. Now, if we, based on the time of the case, if we said any person who have the case within a week, less or up to a week, is a new case. So the incidence will be the number of new cases divided by the population that practice some risk behavior that associate to HIV. So let's say the number of new cases is 20, and we find out that around 100 people in the population practice, for example, safe sex. They have some risk factors, risk behaviors that can lead them to having the HIV. So we divide the 20 by 100, and that will give us the incidence. So those are all the measures based on three: number of cases, size of population, and measure of time. So prevalence, we say the measure the presence of existing cases of disease in a population during a specified time period. And also it involves being in a state that is someone has the disease at the time you are measuring it. They may be cured from the disease in the future. Then the denominator will include all the population, the total population, including the healthy, the sick, those at risk, those not at risk. So the whole population. To find the prevalence, we use the population. That's why we say prevalence is like a proportion of the population who have the disease. All the people who have the disease divided by all the population, total population. So point prevalence is the proportion of population that has the disease at a single point in time. So that's why it's called the point prevalence, at a single point in time. So example here, let's say we have from January 1st to December 31st. At a point in time here, let's say it's July 1st. So we count the number of cases and we divide by the total population. So that will give us the prevalence, the point prevalence in July 1st. So prevalence is normally calculated as the existing cases at time point divided by the total population at time point. So the unit will be the number of people divided by the number of people. So there's no unit. So relevant time period does not appear in the formula, but must be stated using words. if we have any time period. Now we have example here. What is the prevalence of a city A on January 1st, 2017? So the city A has 7,000 people with arthritis on January 1st, 2017. The total population at the same day is 70,000. So to find the prevalence, it will be the existing cases at time period. So the existing cases is 7,000 divided by the total population, which is 70,000. So the answer will be 0.10, which is 10% of the population have arthritis. So the interpretation with the prevalence of arthritis in city A was 10% on January 1st, 2017. Now we have a practice question here. We said a sample of 100 healthy middle-aged women was followed for 9 years. So we can see here we have 2009 to 2017, which is again 9 years. Now, all subjects entered the study on January 1st, 2009, and all women were followed until December 31st, 2017, which is 9 years. None were lost to follow up, and no one died during this period. So during this period, we have 5 subjects were diagnosed with ovarian cancer, but all survived until the end of the study. None were cured. The time at which this subject will develop cancer is shown here. So we have 5 in 2010. We have 1 person have a cancer, 2011, 2012, 2014, and 2016. So those are the 5 people who have the cancer. We didn't have no follow-up to losses or died, nothing. So now the question is, what was the prevalence of the ovarian cancer on January 31st, 2009? They gave us 3 answers here. We divide 5 by 100 or 5%, 5 by 800 or 0.6%, 5 by 5 or 100%, or none of the above. First of all, we have to look at the question if we have a population. Since we don't have no population, we say the answer is 0. There was no population. Let's go back again. Oh, sorry. The sample of 100 healthy middle-aged women was followed up for 9 years. So we have population of 100. None were lost to the follow-up. And during this time, we said in January 31st, we have to look at the time. I was thinking January 31st. Well, the sample of 100, they started from January 1st. January 1st, 2009. So here we are looking at January 31st, 2009. So when we look at January 31st, 2009, there's no any cancer. So it will be 0 over 100, which is 0. Now, they say, what is the prevalence of ovarian cancer on December 31st, 2017? So we have to go back and look at December 31st, 2000. Actually, that's the end. So which means we have 5. This is 2009. Yeah, December 31st, 2017. And by 2017, we have 5 cases. So the answer will be 5 over 100. In January 31st, 2009, in 2009, we don't have no case at all. So it's 0 over 100. Now, a class of preschoolers has 25 students. So our population will be 25 students. On Monday, 5 students reported having gastroenteritis. All were still healed by Wednesday, but 3 had recovered by Thursday morning, no symptoms. By Friday morning, all 5 have recovered. Now the question is, what was the prevalence on Thursday afternoon? So let's go back and check the condition. all were still ill by Wednesday, but 3 had recovered by Thursday morning. So if 3 recovered on Thursday morning, and we have 5, so this means we're going to have 2 by 25, because here it's on Thursday. If it's on Tuesday or Wednesday, then we may have 5 over 25. Now we say, what was the prevalence of the gastroenteritis on Friday afternoon? I think by Friday afternoon, everybody has recovered. So it's 0 by 25, or the 5 recovered. So now let's move to incidence. We say the incidence is the measure of new cases. So measure occurrences of new cases of disease in a population during a specified time period, usually the first time occurrence. This normally involves transition from one state to another. So incidence of disease will be non-disease to disease. Incidence of death means from alive to death. Then incidence of cure means from disease to non-disease. So it's involved transition from one state to another. If I have a disease, that means I'll move from non-disease to have the disease. If I'm in a good health, or if I'm deaf, incidence of death, it means I was alive then died. Incidence of cure means, again, from disease, then I'm cured, non-disease. The denominator only include population at risk. So with incidence, we don't use all the population. And also the number of cases will be only the new cases. So this will exclude people who already have the disease being measured. We're going to exclude people who are immune. For example, they have a vaccination, or here we see a male says immunity from uterine cancer. Uterine cancer normally is for female sex. So prevalence or incidence. Let's see some example for practice. Students in the class who are wearing high glasses today. So that will be prevalence. Students in the class who are wearing high glasses today. Now, students in the class who will start to wear eyeglasses in the next 3 months, this will be incidence. Now, the summary for prevalence versus incidence. Here we say what? Prevalence is always existing disease, but incidence, as we said earlier, new diseases. We can use the prevalence to assess the burden of disease. That's the administration and planning, allocating resources, because we know total number of people who have the problem. But with incidence, we may try to find the cause of the new disease. So etiologic research, what is the causing? What is causing this disease? Now, why we can use for research when incidence difficult to measure. Also, condition with uncertain onset, multiple sclerosis or depression can be one example. But with incidence, evaluation of prevention. Do they work in preventing the new disease, or evaluation of treatment? Do they work in improving survival and quality of life? So incidence, we have 2 types, cumulative incidence and also incidence rate. The new cases of incidence, the difference is how time is incorporated. So this is cumulative and this is incident rate. So cumulative incident, time is described in words that go along with the number. But with incidence rate, time is an intrinsic part of the denominator. That's why it's called rate, the denominator. So with cumulative incidence, we're going to measure the occurrence of new cases of disease in a population during a specified time period. This involves transition from one state to another. Example will be from disease to non-disease, or from alive to death, or from non-disease to disease. The denominator always also is population at risk, because this is incidence. The difference is the time period, the cumulative. So critical assumption, all people in the population have been followed for the entire specified time period. No loss to follow up. So proportion of a population at risk that develop disease over a specified time period. So risk of developing the disease over a specified time period. So cumulative incidence would be the number of new cases during the time period over the number of population at risk at start of the time period. And also it's people over people, so there's no units for it. So we have a practice question here. A class of preschoolers has 25 students. We say on Monday again, 5 students reported having gastroenteritis. All were still healed by Wednesday, but 3 had recovered by Thursday. By Friday, all 5 have recovered. Now, what was the cumulative incidence of gastroenteritis in preschool class over the course of the week? So, which means the whole week, it will be 5 by 25. We have 5 cases. So the cumulative is the period of time, the whole week. Now, example of 100 healthy middle age. So this is the same previous question we have before. We have 100 healthy middle-aged women, and we are monitoring them from 2009 to 2017, the 1st January 2009 to 31st December 2017. And during the process, we have 5 of the female have a cancer. So yeah, we should assume that all the women, the 100 women, still have their ovaries. So now, first question is, what is the cumulative incidence of overall cancer over the 9-year period? So the total 9-year period will be 5. We have 5 cases. Now, what is the cumulative incidence of coronary heart disease over 10 years? Here we say we conduct a study with 1394 participants whom you follow for 10 years in order to measure the cumulative incidence of coronary heart disease in this population. At the time of enrollment, 42 participants already had CHD. During the 10-year follow-up period, 265 participants were diagnosed with CHD. We should note that the denominator measures for cumulative incidence typically do not include the prevalent cases at enrollment and also the immune individuals, because the enrollment and the immune individuals, they are not at risk for the disease, which is CHD, coronary heart disease. So we have 1394 participants. At the time of enrollment, 42 participants already had a CHD, and 265 participants were diagnosed with CHD. So the cumulative incidence will be the number of new cases during the time period over the number of population at risk at the start of the time period. Remember, this is 10-year time period. So the number of new cases is 265. Population at risk, remember 42 is out, the enrollment of 42. So we subtract 1395 minus 42. Now, if we have people with vaccination against this disease, we're also going to subtract them. So we have 265, 1352. So the cumulative incidence for 10-year period will be 19.6%. So the cumulative incidence of CHD was 19.6% over the 10-year follow-up. So we have different special types of cumulative incidence. Example is the attack rate, which is the proportion of individuals exposed to an infectious agent who become infected over a certain period of time. So that will be the new cases of disease divided by population at risk at the beginning of the time. during a specified time period. We also have the case fatality rate, which is proportion of individuals with disease who die of that disease. So the death due to disease X over population with the disease X. So next we move to the incident rate. Incident rate also measures speed at which new cases of disease occur in a population. The key word again is new cases incidence. But rate means in the denominator will be going by time. So this involves transition from one state to another, from non-disease to disease, or from disease to non-disease, or from alive to death, which means incidence of death. So the denominator only includes population at risk. Here we do not assume the group of people being observed has been followed for the entire time period of observation. That would be the cumulative. So with the incident rate is equal to true rate, which is other commonly encountered true rates. For example, miles per hour. The denominator is hourly time. Gallons per minute, again, is time. Rate means the denominator goes with time. So what makes this true rates? Time is taken into account as part of the calculation. So incident rate will be the number of new cases during some time period over total person time of observation in population at risk. So time is included in the denominator, the number of people times time. So what is person time? The amount of time each person at risk is under observation. The amount of time each person at risk is under observation is the person time. So this can be accrued only among persons at risk. Also, it can be accrued only while being followed. That is the follow-up time. So the accrues normally ends when a person is no longer part of the population at risk, which is developed disease under study or dies, or is lost to a follow-up, moves away or quit the study, or no longer meets the eligibility criteria. So each person contributes different amount of person time to the denominator. So example of how person time is accrued. We have person 1 up to person 5. January 2014 we start. Person 4. January 2015. Person 1 to January 2016 has a disease of interest. Person 4, again, January 2017 have a case. So the total person here, we have one person here in the person 1. In person 2, also one person here. Then person 3, 3 person years and 2 person years. So we have total of 7 person years based on the interval here. So here we have from January 2015 to January 2016, so 1 person here. This is from January 2016 to 2007, so 1 person here. Person 3 is from January 2015 to December 2017, so that's 3 person here. Then person 4 is from January 2015 to December 2016, so it's 2 person here. When we add all, we get 7 total person here. Person 5 is 0. So here we have a total cases of disease is 2, DD. So several ways to accept or to accrue the person time. Example here, we have 100 person years can be accrued in different ways. 100 people follow 1 year each, or 10 people follow 10 years each, or 25 people follow 4 years each. 25 times 4 is still 100. 100 times 1 is 100, 10 times 10 is 100. So there's many other combinations depending on the individual follow-up times. So these rates are identical, 2.5 by 100 or 25 by 100 or 250 by 10,000 is the same time identical. So now the next example is what is the incidence rate of hypertension in a cohort of US Black women? Here we have a follow-up of 30,330 women from 1997 to 2001. 104,475 person here, 2,314 cases were stent during the follow-up. So incident rate will be number of new cases during the time period over total person time of observation population at risk. We have 2314, the new cases, then 104,574 person here, total PY. Then we get the value. So during the study period, the incidence rate of hypertension was 2,215 by 100,000 person here. Now, relationship between prevalence and incidence, and again, as we said earlier, prevalence deal with all the cases, incidence deal with only new cases. So to be prevalent case, an individual has to have been an incident case at some point of time. At some point it was a new case, but later it's now an old case, and still have the disease. So duration, the time living with the disease is also involved. But incidents only deal with the new cases. So the diagram here, we have incident, then tend to prevalent. It can be a cure, or still takes time, still have the disease, or there will be a death. So those are the three outcomes. If I have a disease, either the disease still exists with time, or we were able to cure it at some point of time, or maybe we die for it. So relationship between prevalence and, again, incident rate. Prevalence is approximately equal to incident rate times D. D is the average duration of disease. That is the time from the diagnosis to recovery or death. Duration of disease will have only two options. Either the person die from the disease or recover from the disease. So the prevalence is always approximately the incidence rate times the average duration of the disease. And also, we always start with incidence. At some point in time, the new case becomes the old case with time, tend to prevalence. Now, when we are in prevalence, either the disease will be cured or there will be death. And that's the only way we can get rid of the disease. So disease always starts with incidence, a new case. Later with time, it becomes the old case. That's where prevalence involves. Then the disease may disappear, either it killed a person or we were able to cure. So to find the duration of the disease, then it will be prevalence divided by incidence rate. So incidence rate of a lung cancer, let's say we have 49.9 by 100,000 person here. The prevalence of lung cancer will be 23 by 100,000 persons. If we know these two, then the average duration of the lung cancer will be the prevalence, which is 23,000 by 100,000 persons over incident rate, which will be 49.9 by 100. So the duration of the disease, if we do this calculation, it will be 0.5 years. So always the duration of the disease will be the prevalence divided by the incidence rate. So we have some question on prevalence and incidence rate. What will happen if you introduce a primary prevention effort to reduce exposure to HIV? So we say the incidence of HIV infection in population, here we are going to have a decrease. because here, again, we introduce a primary prevention effort to reduce the exposure to HIV. So maybe safe sex, other safety measures to reduce the HIV. Now, prevalence of HIV infection in population, this will decrease it also. Since we reduce the exposure, the prevalence value also will decrease. What will happen if you introduce a new treatment for type 2 diabetes that prolongs the life of diabetes? So the incidence of the diabetes in this population, of course, no identifiable effect because we prolong the life of diabetes. But with prevalence, we are going to increase it since the diabetes will be longer, so it will increase. So in summary, we put all together, we have prevalence, cumulative incidence, and incidence rate. So incidence rate is new cases divided by person time at risk. Cumulative incidence will be new cases divided by population at risk, and prevalence will be existing cases divided by total population. So prevalence will be proportion, cumulative incidence also is proportion, but incidence rate is with time, so it's a rate. There's no units for both prevalence and cumulative, but incident rate is 1 by time, go by time, per year, per week, etc. The range, of course, will be 0 to 1 for both because these are percentages of proportion, but incident rate from 0 to infinity. Numerator will be an existing cases for prevalence. Numerator will be a new cases for incidence, and incidence rate also is new cases. Denominator, we have the total population. With incidence, it will be population that at risk. And we know incidence rate go with person time. So person time at risk. So again, to find the prevalence, we say it's always the incidence rate times the disease. So to look for a disease, it will be prevalence divided by the incidence rate. And the D disease is the duration of the disease. So we should remember this, again, reporting prevalence, cumulative incidence, and incidence rate. That's the main three things we cover in these lectures. So we have some practice question here. Which type of disease frequency, P, CI, that is a cumulative incidence or incidence rate? So here we say percentage of nursing home residents who contracted influenza during the course of an outbreak. Here we have a period of time from January 1st to 20, so it's cumulative incidence. Percentage of potential army recruits rejected at intake exam because of poor vision. So there's no period of time here, so this will be our prevalence. The number of code diagnosed in 1,000 person here within, and so the keyword is person years time. So this will be incident rate. Then percent of live-born infants with cardiac malformation among 100,000 live births. So this will be again prevalence. And we have another example, a population of 100 healthy men was followed for development of prostate cancer. 20 men developed prostate cancer after being followed for 5 years. Another 10 men were followed for 1 year and they were lost to follow up. The remaining 70 men were followed up for 10 years and never developed prostate cancer. Now we are going to calculate the number of person years observation accrued by this population. So we may have 20 times 5, because we have again 20 men develop prostate cancer after being followed for 5 years. So the person time 20 times 5 plus we have 10 times 1 year. Another 10 men were followed for 1 year and they were lost to follow up. Then the remaining 70 were followed for 10 years, so 70 times 10. So this will give us 810 person years. Here we are calculating the number of person years of observation accrued by this population. Now we have some few questions here, true, false. Only the population at risk contributes to the denominator of cumulative incidence. So this will be true. Now let's look, next question. When calculating the incidence rate of disease, it is necessary to follow subjects for the same amount of time. That is false. If the incidence rate of a very serious disease is 75 by 100,000 person years, and the prevalence of disease in the population is 25 by 100, then the average duration of this disease must be 3 years. And that's correct because we are going to divide 70, the incidence by, the incidence, if incidence rate of the very serious is 20, is okay, 75. So it will be the opposite rather. We divide the prevalence by the incidence. So that would be 1/3, not 3. All other things be equal, when treatment is developed that prolongs the life of people with a disease, the prevalence of the disease will increase over time. And that is again true because it's going to prolong the life of the people with disease. So we are going to have many people with the disease, so the prevalence of the disease will increase. Also, we know that the prevalence is equal to incidence rate times disease duration. So to find disease duration, it will be prevalence divided by incidence rate. The prevalence here is 25 by 100,000. Incident rate is 75 by 100. So it will be 25 divided by 75. That will give us 1/3. So incidence rate calculation, again, a total of 60 cases of myocardial infarction, which is heart attack, were reported over a period of 2 years in a city with a population of 100,000 people. Using this data, we should estimate the incident rate of the myocardial infarction per 100,000 person year. State any assumption that are needed. So the first thing, we have 60 cases were reported over 2 years in a population of 100,000. So 60 by 100,000 will give us the person years, and it's 2 years. So 60 by 100,000 persons times 2, or we reduce it to 30 by 100,000. Now, assuming that everyone follow for the entire 2 years, and that all cases occur at the end of the second year, different assumptions can be made regarding the length of follow-up for cases and non-cases. So this will be the conclusion of our lectures on the measures of disease. Again, these lectures we discuss about prevalence, cumulative incidence, incidence rate, and we find the difference of them and also the formulas how to calculate them. So again, wish everybody the best. Thank you.